Acha, the questions that I've taken out are basically from IGCSE, okay? But don't think that they're any different from O levels. They're the same, and it's just good practice, okay? So just give me a minute, we'll start. Okay. So since we're done with all the concepts, now is a good time to do past paper questions. So this is a question. This is from February, March. As you know, IGC has a session in February, March as well. Paper 4. Okay. So it says here, the volume of a paper cone of radius 2.4 centimeter is 95.4 centimeter cube. So this is the cone the question's talking about. The paper is cut along the slant height from O to AB. The cone is opened to form a sector OAB of a circle with center O. Now, if you remember, I made you guys write down an important point, and that was that if you cut open a 3D object and form some other object, there's one thing that remains the same. Ek to tha, when you melt one object and form another object, something remains the same. And then there was another where I said that if you cut open an object and use it to form some other object, what is the one thing that remains the same? Let's see if you guys remember. No. Volume is for when you melt it. There's the surface area. Okay, so I've written over here, and this is the example that you'll find very common, especially with a cone, where that you cut open a cone, it becomes a sector, and then we have to find out something or the other of the sector. Okay, so it says when one object is cut and another one is formed using the same amount of paper, the total surface area remains the same. Okay, volume remains the same when you melt one object and form another. Okay, so here we are. It says the volume of a paper cone of radius 2.4 centimeter is 95.4 centimeter cube. Okay, so with the help of that, if you think about it, we can find out the height of the cone. Okay, now let's see if that is even necessary or something like that. Okay, let's first see how many marks this is. It's a 6-mark question, so that means there's a decent amount of working that's required before we can get our final answer. Okay. The cone is open to form a sector OAB of a circle center O. Calculate the sector angle x degrees. Okay. Now, there are a lot of concepts that we can use over here. One is that we can say that the slant height of the cone OA will be equal to this radius of the sector. Okay. The other thing is that we can say that the circumference of the circle, okay, will be equal to the arc length. So there's a whole bunch of things going on over here, and you got to make sure that you're able to pick every single one of them. So first of all, these two lengths will be the same. The slant, the circumference of the circle will be equal to the arc length. Okay, now I want you guys to take a look at this in case you've forgotten. This is something that we did when we were studying cone. So I want you to ignore the circular part, okay, and I want you to focus on just the curved part. So notice what happens. If you focus on this length, okay, this length, the arc length of the sector, notice that the arc length comes directly on top of the circle. What does that mean? That means when it's a cone, the circumference of the circle is actually equal to the arc length. Okay, now there's something else going on. One is that the area remains the same. I've already mentioned that. And the other thing that I want you to do is look at the slant, look at the radius of the sector and see what it turns into when we fold it back. When we fold it back, it turns into the slant height of the cone. Okay, now keeping all that in mind, let's see what we can do over here. Let me highlight this and this so you guys remember. Acha. So first things first, let's find out the height of the cone. Okay, can we find the height of the cone? Yes, we can. Why? Because we have the volume of the cone. So the volume of the cone, the formula for that is given, is equal to 1 upon 3 pi r square h. Okay, so there's no need to actually write down the formula again. I'll just start solving it directly. So 95.4 equals to 1 upon 3 into pi into r, which is 2.4, okay, square times the height. Okay, so what will this give me? This will give me the height of the cone. Okay, so 95.4 into 3 divided by pi divided by 2.4 squared. So here I am looking at the height, which is 15.8 centimeter. Okay, so the height of the cone is 15.8 centimeter. Now, how do you think the height and the radius will help me find out the arc length? Find out the slant height. which will then be equal to the arc length. How do you think that will help? There's something we can use. Pythagoras theorem, right? Sorry? What did you say?
I thought you were asking how it's going to help us.
Oh, okay, yeah. So basically, the slant height, as we know, will be equal to the square root of 5.8 squared plus 2.4 squared. Why? Because it's a right angle triangle, and if it's a right angle triangle, that means we can apply Pythagoras theorem. Okay, so if you work this out, so let's square this plus 2.4 squared, and then let's take the square root of it. So we're looking at 15.997. 15.99. So since it's not the final answer, we'll keep it as 15.99 only. Okay. Now this slant height is actually equal to what? This slant height is actually equal to OA, which is the arc length. Okay. Now, how can I find out? Sorry, not the arc length. I think I said arc length. I meant the radius. Okay. So we have the radius, which is equal to 15.99. So yeah, we need to find x. So that means there is still one missing piece of the puzzle. Okay. Now, how will we get that missing piece of the puzzle? That we will get by finding out the circumference of the circle. Okay, so if you find out the circumference of the circle, and why are we doing that? Because you can see I've highlighted it. The circumference of the circle is equal to the arc length. So the circumference of the circle, 2 pi r, is going to be 2 into pi into 2.4. Okay, now we'll keep this in terms of pi only. Okay, why? Because if you keep it in terms of pi, you know, pi and pi will get cancelled out. So 2 into 2.4, actually I don't need a calculator for that, that's going to be 4.8 pi. Okay, so this is what? This is AB, the arc length. So that's it. We have enough information now to find out the angle x. So what do you think will be that will just connect everything? The radius, the arc length. What formula do you think will connect the arc length? Or rather, what formula am I going to use over here? Chalo, let me put it to you that way, which will then help.
360 into 2 pi r.
Very good. X upon 360 into 2 pi r. So x upon 360 into 2 pi r. So we already have the radius, which is 15.99, will give me the arc length, which is something we've already worked out, and that's 4.8 pi. And now you can probably see why I kept it in terms of pi only. So pi and pi gets cancelled out. Okay, now with a bit of cross multiplication, so 4.8 times 360 divided by 2 divided by 15.99 gives us the value of x, which is equal to 54.0 degrees. So normally any angle is given correct to one decimal place, so we'll write 54.0 degrees. Now there is something else that I could have used, and I mentioned that earlier as well. I could have also used the area. Okay, so that's what I asked you guys initially as well, that what remains the same, the area. So I could have found out the curved surface area of the cone and equated that with the formula for the area of sector. Okay, so just make sure that whatever it is that you're using, you're equating it with the appropriate formula. Now, any questions about what I've done? Anything that you guys don't understand? Okay, great. So here's part B. Let's see what part B says. So part B, by the looks of it, yeah, it's going to be an independent of part B, because what we just did was part A. So it's not like this is A part 1 or part 2. It's part B, so that means it's completely independent. So it says here, an empty fuel tank is filled using a cylindrical pipe with diameter 8 centimeter. Fuel flows along this pipe at a rate of 2 meters per second. So you can see there are so many traps set up in this question. Diameter is in 8 centimeter. The length of the pipe, or the length of the water flow, is in meters per second. Okay, and now we have the time, which is in minutes. So it says that it takes 24 minutes to fill the tank. Okay, calculate the capacity of the tank. Give your answer in liters. Okay, now let's read the question again, this time a lot more slowly, so that we really understand what we have to do. So an empty fuel tank is filled using a cylindrical pipe with diameter 8 centimeter. Okay, so the shape that we're dealing with over here is a cylinder. Okay, fuel flows along this pipe at a rate of 2 meters per second. It takes 24 minutes to fill the tank. Calculate the capacity of the tank. Give your answer in liters. Okay, now, so if I can somehow find out the volume that has flowed in 24 minutes from the pipe into the tank, that would be equal to the volume of the tank. Okay, so first of all, let's get all the units sorted out. Okay. Now my suggestion. Yeah, is someone saying something?
So can you please repeat what you said? How will we find the volume?
So if I can somehow find out the amount of water, which is the volume of the water that has passed through the pipe, that would be in 24 minutes, of course, that would give me the volume of the cylindrical, the volume of the fuel tank. Now we don't, if you notice, the question did not give you the shape. So basically, if I can somehow find out the total amount of water that flows through the pipe in 24 minutes, that would give me the amount of, that would basically give me the volume of the cylindrical tank, the volume of the tank, okay? Whatever the shape it may be, whether it's cubical or cylindrical, doesn't matter, okay? So let's first try and visualize what exactly is going on over here. So we have a cylindrical pipe that we know for sure, okay? And we know that in that cylindrical pipe, in 1 second, the water flows 2 meters, okay? So if let's say we just freeze the water, if let's say that in the pipe, we just for a second freeze the water, okay? So what would be the height, or let's say what would be the length of the water in the pipe? That would be 2 meters, which is equal to what? Which is equal to 200 centimeter. Now this is what's happening every second, okay? This is what's going on every second. So if I can somehow find out the volume that flows through the pipe in 1 second, and then just multiply it by whatever time it takes to fill the tank, that would give me the total volume, okay? Now why did I convert 2 meters to 2 centimeter? That's because one unit is in centimeter and the other was in meter. And also the reason why I converted is because we have to give our answer in liters. And remember, 1 liter is equal to what? 1 liter is equals to 1,000 centimeter cube. Okay, so it's best that you, anything to do with volume where you have to give your answer in liters, it's best to keep your answer, to keep all units in centimeters. Okay. Now another catch in this question is the fact that you're given the diameter. So make sure to convert it to the radius, which is going to be 4 centimeter. Okay. Now let's see the volume of water in 1 second. Okay, the amount of volume that flows through the cylindrical pipe in just 1 second. So here's what we're going to do. Pi into 4 squared into 200. Okay, so let's work this out. Pi into 4 squared into 200. So here we are, we're looking at 3200 pi. Okay, now don't convert this just as yet, we'll do that later. Now this happens for a total of how many minutes? 24 minutes. So what do you think? Should I multiply this by 24 or should I multiply this by something else?
3600?
No, not 3600.
Or 60?
Yes, 24 times 60. Why 24 times 60? Because I need to convert 24 minutes into seconds. Okay. So when you multiply this, you will then have the volume of water in 24 seconds. Volume of, I say it doesn't say anywhere that it's water, I just realized. But yeah, whatever fluid it is. Okay. Fuel actually. Yeah, it says it's fuel. So let me change that. Not that we're going to lose marks or anything, but volume of fuel in 24 minutes. So here's what we're going to do. We're going to multiply it by 24 and 60. So let's see, what do we get? 3200 pi into 24 into 60. So we're looking at a very gigantic number. I'll write it down, but it's not a final answer. And the number is basically 1447654.8.95. And clearly this is not the final answer. Why? Because it's in centimeter cube. Now how will I convert centimeter cube to liters? I will divide it by 1000. So let's divide it by 1000. So here's what we're looking at. We're looking at 1000, in fact 14,476.45. And then if you give your answer correct to 3 significant figures, which you have to, you have 14,500 liters as your final answer. All right, now let's do another question. So here's a question. Let me, share it with you guys. Here it is. Let's see what it says. It says the diagram shows a solid cone and a solid hemisphere. So let's highlight that. Solid cone and a solid hemisphere. The cone has a radius of 2.4 centimeter and slant height 6.3 centimeter. The hemisphere has radius or centimeter. the total surface area of the cone is equal to the total surface area of the hemisphere. Okay, calculate the value of r. Now notice that this is a solid hemisphere. The formula that we learned for hemisphere is not for a solid hemisphere. It is for a hollow hemisphere. Remember that. Okay, and I said this earlier that there are very rare cases that you have come across a solid hemisphere, such that the top part is also uh, solid and it's not open from the inside. So in that case, what do you think would be the volume? Volume will remain the same. Sorry, my bad. What do you think will be the total surface area of a solid hemisphere?
4 pi r square plus pi r square.
2 pi r square. 2 pi r square for the curved part, the curved surface area, plus the circular base, which will be pi r square. Okay, so 2 pi r square plus pi r square, which then eventually becomes 3 pi r square. Okay, so this is for a solid hemisphere. Okay, acha. Now let's come back. Okay, so let's see what it says. It says the total surface area of the cone is equal to the total surface area of the hemisphere. Calculate the value of r. Okay, now you can see that the formulas are given, but the formula that's given is for the curved surface area of a cone and the curved surface area of a sphere. So you got to be extremely careful. Okay, so how do we calculate the total surface area of a cone? What are we going to do? Pi. Yep, so pi r square, that means the area of the base plus the curved surface area. So thankfully we already have the slant height, so there's nothing to worry about. Pi into 2.4 into 6.3. Okay, so that is the total surface area of a cone. This is equal to the total surface area of a solid hemisphere, which as we just saw is 3 pi r square. Okay, now since we have pi on all the sides, so it's my suggestion that you cross it out so you don't have to deal with it. Okay, and you just work out, you just make r square the subject. So if you make r square the subject, here's what you're going to do. 2.4 squared plus 2.4 into 6.3. Okay, so I'm looking at a certain value, which I'll tell you what it is. It's 20.88. So now I'll just directly tell you guys what the value of r is. So first we'll divide it by 3. Then when you take the square root, so you're looking at 2.63 centimeter. And there you go, fellas. That's your answer. So this was a pretty easy one. Okay. Now, if you guys have any questions, feel free to ask. Sir, how did you conclude that the total surface area of a closed hemisphere to be 3 pi r squared? Okay. So I just showed you that. So basically, here we have the formula for 2 pi for a hemisphere which is hollow. Okay, now this is, so we have this understanding that when we're finding out the total surface area of a sphere and volume, we're talking about a hollow sphere, which is why when you look at the formula for the hemisphere, it's only 2 pi r squared. And how did we get to 2 pi r squared from 4 pi r squared? By simply dividing it by 2. Okay, but like I said, we have this understanding that this is for a hollow hemisphere. But what if you have a solid hemisphere? So that means it's not just the curved part. CSA is short for curved surface area. So it's not just the curved part, there is also the circular base, you can say, or the top, depends on how you're holding it. Okay, so that is circular, which means another pi r square. So therefore 2 pi r square plus pi r square equals to 3 pi r square. Okay, all right, now this is the same question and this is part B of it. Okay, let's see what it says. So it says the diagram shows a solid cone with radius 7.6 centimeter and height 116 centimeter. Okay, a cut is made parallel to the base of the cone and the top section is removed. So you can see that you've actually removed a cone. Okay, what you've removed is actually a cone. So let's add a bit of a 3D touch to it. So this is basically what you've removed. Okay, now then the question says the remaining solid has height 12 centimeter as shown in the diagram. Okay, calculate the volume of the remaining solid. Okay, now theoretically, how do you think we're going to do this question? Like, don't get into the calculations just as yet, but just tell me theoretically, what is it that we're going to do? What are we going to do?
Calculate the total and then minus the smaller part.
That is true. That's exactly what we're going to do. So let's add the cone over here that we have removed. Okay, so this is the cone that we have removed. Okay. Now we have the leftover height, but we also have the total height. So that means somehow using this information, we can calculate what? So you guys tell me, what can I calculate that you think will help me? Can I calculate the height of the smaller cone? Can I do that? Yeah, I can totally do that. So that would be equal to 16 minus 12, which is equal to 4 centimeter. Okay, so we have the height of the smaller cone, but that's still not enough. I mean, theoretically, we've worked out what we're going to do. Okay, so we'll calculate the volume of larger cone, and from it we will subtract the volume of the smaller cone. Okay, so theoretically it's all sorted out. As far as the volume of the larger cone is concerned, we can work that out in a second. 1 upon 3 pi r square into the height. Okay, but as far as the volume of the smaller cone is concerned, well, things aren't looking very bright over here. Why is that? That's because we have the height, okay, but we don't have the radius. We don't have the radius. That's true. So can you think of a way, and we've just done this, by the way, through which we can find the radius? Okay, so I'll give you guys a hint. It's a no, it's on Pythagoras. So, well, one hint is that we've just done this topic. I'm thinking of some other hint which is not too obvious. Let me think. Sorry? Okay, I can't. Your voice is very low today for some reason. I can't. It's very difficult trying to understand what you're saying.
I have a different headphone today.
Yeah, I can tell.
We are direct.
Yeah, up say. Sorry?
Direct proportion. Like.
Yeah. What exactly is the concept behind? You're right, direct proportion, but what exactly is the underlying concept here?
Like we have the radius of for the larger cone, we don't have the radius, but we do have the height of the cone. So we're gonna proportional then we will have.
Okay, I agree. I completely agree. But what is the concept? And I'm sure with that information you will be able to find out exactly what we want. But what exactly is the concept over here? So I'll give you a hint. It starts with the word yes. The concept here is similar triangles. So the two triangles, basically the one in red that I'm highlighting and now the one in green that I'm highlighting, they're basically similar. Okay. So basically the ratio of their heights will be the ratio of the areas. So what is the height of the smaller cone? It's 4. What is the height of the larger cone? Is 16. What's the radius of the larger cone? Is 7.6. What's the radius of the smaller cone? Let's call it x for the time being. Okay. So basically here's what you can do. 16 divided by 4, basically the ratio of the heights is going to be the same as the ratio of the radii. Now if you cross multiply 7.6 times 4 divided by 16, so we're looking at 1.9. So x equals to what? X equals to 1.9. So that means now we have the radius of the smaller cone as well. Now it's just time to put it all together and we can have our final answer. So there you go. Let's work this out, see what do we get. So this requires a decent amount of calculation. Here's one thing that I would suggest. So in both these, just to make your life easy, okay, you don't really have to do this, but it's just one of those things that are good to know. So basically, both of them have 1 upon 3 pi common. And obviously, they'll have 1 upon 3 pi common because they're both cones, okay? So what I'm going to do in my calculator is I will just work out this part, 7.6 square into 16 minus 1.9 square into 4. And then once I have that, I'll simply multiply it by 1 upon 3 pi. So that way I don't have to write 1 upon 3 pi again and again. So I'll save a few seconds over there. So 1.9 square into 4, close the bracket, into 1 divided by 3 into pi. So here we are looking at, so just write answer over here. Okay. So what I'm looking at is 952.656 something, but then again when we give our final answer we will say 953 centimeter cube. Now there you go, that's the answer. Now any questions? If there's anything that's not clear, feel free to ask, because I'm about to give you guys a question to solve on your own. So let's see what this question says. And by the way, this question is from October-November 2021. Okay, so fairly recent. So it says here, the diagram shows a container for storing grain. Okay. The container is made from a hemisphere and a cylinder and a cone. Okay, so there are three shapes altogether: a hemisphere, cylinder, and a cone. Okay. Calculate the volume of the hemisphere. Give your answer as a multiple of pi. Okay. So hemisphere, we are given the formula for calculating the volume of a sphere. If it's a hemisphere, don't forget to divide by 2. So 4 upon 3 divided by 2 is 2 upon 3 pi r cube. Everything else remains the same. So 2 upon 3 into pi into r, which is 2 cubed. Okay. So 2 cube is 8. 8 times 2 is 16. So 16 upon 3 pi. Since the question said give your answer in terms of pi, so please do give your answer in terms of pi. Okay. Now then, I'm sorry?
5 1 over 3 pi.
Yeah, you can write it like that as well. 5 whole 1 upon 3. As long as it's in terms of pi, that's fine. But just don't use decimal. If you're using decimal, then be smart about it. Write 5.33 with a recurring sign. Okay, but I wouldn't recommend that you go all the way out and do that. Just 16 upon 3 is good enough, or even 5 whole 1 upon 3 is good enough. Okay. Alright, then comes part 2. It says the total volume of the container is 88 upon 3 pi meter cube. Calculate the value of h, the volume of the cone. Okay, so then you're given the formula for volume. So let's first plan our answer, because there's a whole bunch of stuff that's going on over here. So we have altogether 3 shapes to deal with. Okay, so we have a cone, we have a cylinder, and we have a hemisphere. And remember, for composite solids, doesn't matter how many solids you keep on topping up or you keep on adding, the formula for calculating the volume remains the same. I think I've written that here somewhere. I don't know. When one object is cut. Okay, I haven't written that for volume, but I think I mentioned that earlier, that the formula for volume remains the same. Okay. So we start by calculating the volume of a hemisphere. So we've already done that. We've done that here. It's 16 upon 3 pi. And since the volume that's given to you is in terms of pi, so I would suggest that you also keep your volume in terms of pi. Okay. Then we calculate the volume of the cylinder, which would be pi r square h. So pi into 2 square into the height, which is 5.2, plus the volume of a cone, which is equal to 1 upon 3 pi r square h. And this is equal to what? This is equal to 88 upon 3 pi. So basically, this becomes 20.8 pi plus 4 upon 3 pi h plus 16 upon 3 pi, which is equal to 88 upon 3 pi. Okay, and we can take pi common from the left hand side, and we can cross that pi out with the pi that's on the right hand side. Okay, so here's what we're looking at: 16 upon 3 plus 20.8 plus 4 upon 3h, which is equal to 88 upon 3. Okay, now 88 upon 3, from it we subtract 20.8, and from it we also subtract 16 upon 3. Okay, so 20.8 goes over to the other side, 16 upon 3 also goes over to the other side. So here's what we're looking at. We're looking at 4 upon 3h, which is equal to 16 upon 5. Now 16 upon 5 gets multiplied by 3, and then you divide it by 4. So h is equals to 12 upon 5, or you can write it as 2.4 centimeter. Centimeter and meter, but yeah, meter. And there you go. That's your answer. So it's more of a, see, once you have the formulas, then it becomes more of a test of algebraic manipulation than of mensuration. So yeah. Okay, now here's part 3 and part B. Let's quickly go over these two parts as well. So it says the container is now full of grain. Grain is removed from the container at a rate of 35,000 kg per hour. 1 meter cube of grain has a mass of 620 kg. Calculate the time taken to empty the container. Give your answer in hours and minutes. Okay, how many marks is this? This is 3 marks. Okay. So first of all, let's read the question again. Grain is removed at a rate of 35,000 kg per hour. 1 meter cube of grain has a mass of 620 kg. So first of all, let's find out the volume of the container. Okay, now the question is, do we really have to find that out? No, we don't. Okay, it's already given to us. Now, if we're given the volume, and if we have the ratio of volume to mass, that means here's what we can do. We can find out the mass of grain in the container. So we know that 1 meter cube of volume, let's make sure it's in meter cube, yeah. So 1 meter cube of volume means that 620 kg of mass. So here's mass in kg, and here's volume in meter cube. We have 88 upon 3 pi in our container. So how much mass would that be? Let's cross multiply, see what do we get. So 620 into 88 divided by 3. So let's keep it in terms of pi. Since it's not the final answer, let's keep it in terms of pi. So we're looking at 54,560 upon 3 pi kg. Okay, this is what we're looking at. Let me write that again. 54,560 upon 3 pi kg. Okay. Now we know that in 1 hour, the grain is removed. The amount of grain that's removed is 35,000 kg. So here is time and here is the mass. Now how much grain do we have to remove? We have to remove 54,560 pi upon 3. How long will that take? It's going to take x. Okay. Now let's cross multiply. So x would basically be equal to 54,560 pi upon 3 divided by 35,000. So the last answer I still have in my calculator, so I'm just going to straight away divide it by 35,000. So divide by 35,000. So here's what I'm looking at. I am looking at, just a minute. Oh, I've subtracted 35,000. Wait, I was wondering how come the value so. Okay, so that means I have to do it all over again. 54,560 divided by pi divided by 3. So divided by 35,000. Yep, this makes more sense. So here we are looking at 1.63 hours. Now I don't know if you guys are aware. In fact, you should be aware. I've mentioned it quite a few times. There is that key in your calculator which allows you to see how many hours and how many minutes there are. Okay, it's just underneath this square root key. You'll see that there's something like this written on it. You'll have like a degree sign and then a single apostrophe and then a double apostrophe. So when you press that, it gives it to you in hours and minutes and seconds. So 1.63 is equal to 1 hour. And then we have 37 seconds and 56.75 seconds. So here's what I'm looking at. 1 hour, 37 minutes, 56.75 seconds. So this degree sign is for hours, the single apostrophe is for minute, and then the double apostrophe is for seconds. So when we round this off correct to the nearest minute, what do you think will it's going to be? 37 minutes or 38 minutes? 38. Why? Because it's 57. And you know that after 59, the minutes increase by 1. So here we have 1 hour and 38 minutes. Now let's say you didn't know how to do this. Okay. Although my suggestion is that you do learn it, but let's say you don't know how to do this. So what you can do is from the 1.63, you know for sure that it's going to be 1 hour something. So you subtract the 1 and then you just find out how many minutes 0.63 of an hour is, for which you multiply it by 60 and you will have 1 hour and 38 minutes. I mean, you'll have 38 minutes, but you know that 1 hour is already there. So 1 hour, 38 minutes becomes our final answer. Okay. Now here's another question. I mean, not another question, but just part B of the same question. It's pretty easy. It's a bit of mensuration and a bit of trigonometry. So by the way, I hope everyone understands this part. In case it's not clear, please feel free to ask. Okay, great. Acha. So it says here A and B are points on a circle. Center O, radius r centimeter. The area of the shaded segment is 65 centimeters square. Calculate the value of r. Now this is what a segment is. Okay, you guys should know this from before. Sir, won't be divided by 60 if we were to do it manually? No, you won't divide it by 60. You'll multiply it by 60 because you have it in hours. 1.632 are basically the hours, not the minutes. So 1.632 means that you have 1 complete hour. Now you need to find out how many minutes there are in 0.632 of an hour, for which you multiply it by 60. How do you convert hours to minutes? You multiply it by 60. It's like how many hours and minutes is 1.5 hours. So you know that the 1 means that there is 1 complete hour, and then what's left if you take away the 1.5 is left, which you multiply by 60. So you have 30 minutes. So we're doing pretty much the same thing with 1.632. So you take away the 1, you know for sure it's 1 hour. And then in order to find out the remaining minutes, you take the remaining value and multiply it by 60. Okay, so I hope that helps. Okay, so as I was saying, this is what a segment is, what I've shaded. Now, how do you think I can calculate this area, this shaded area? Tell me the working behind.
So find the
Mm-hmm.
find the area of the sector and then divide it by the like we find the
Div-
triangle.
divide or
area and the subtract.
subtract? Yes. So that's what we're going to do theoretically. Area of sector minus the area of the triangle. Okay. So how will I calculate the area of sector? 140 upon 360 into pi r square. And how will I calculate the area of triangle? I'm going to use this sine formula. Half into r into sine 140. Now from this point onwards, it's not a mensuration or trigonometry question. It is an algebra question. Okay, how well you can how good are your algebraic manipulation skills? That is what it all boils down to now. So first of all, we have to find out the value of r, right? So first thing that I'm going to do is I'm going to take r square common. Okay, why? Because if you multiply these two together, you get r square as well. So half r square, so let's write it, sine 140 equals to 65. And then if you want, you can do a bit of simplification over here. So let's do that. In fact, while we're at it, 140 divided by 360 is 7 upon 18. So 7 upon 18 pi r square. Okay. The answer is 53.5. Let me check. The answer is in fact 8.4. Can't be 53.5. How can the radius be 53.5 and the shaded area be 65? So that doesn't make sense. Anyway, koi baat nahi. You'll see what you've done wrong. So let's take r square common. So we have 7 upon 18 pi minus 1 upon 2 sine 140. Sorry, not sine 40, sine 140, which is equal to what? Which is equal to 65. Now I can make r square the subject, and if I do that, it's going to be 65 divided by 7 upon 18 pi minus 1 upon 2 sine 140. Okay, now if I've done everything correctly, and then don't forget to take the square root of the answer. And what's the answer going to be? This is the answer. So I'm going to use the calculator from this point onwards. 65 divided by 7 upon 18 pi minus 1 upon 2 sine 140. So just plug it in your calculator exactly how you see it, okay? So I'm looking at r square equal to 72.19 something. So in order to find out the value of r, like I said, we'll take the square root of the answer. So 8.496 is what I'm looking at. 8.496, which then if we give our answer correct to three significant figures, becomes 8.50. So there you go. That, like I said, from this point onwards, it was more of a algebra question than a mensuration or a trigonometry question. Okay. Now, any questions? Anything that's not clear?